back to the Mom Mentality Show. I'm Chris Lucian, and our co-host here is Austin Chadwick. And today we have the honor of having Dragan Stepanovic with us, and we are going to talk about async code reviews, XP, lean, and theory of constraints. So first, Dragan, would you like to just introduce yourself a little bit and talk about your interest in the space, and then we can talk a little bit about async code reviews and then move on.
Sure. Thanks for having me. So yeah, I've been in the XP community for quite a long time now. I entered the rabbit hole a long time ago, and I'm still in this kind of rabbit hole, but always on the lookout for different ways of working. And that's kind of how I started my career. After that, some other topics kind of came also in my interest zone, which was mostly about domain-driven design, architecture, high-scale distributed systems. And then I think 4 or 5 years ago, I started diving deeper into topics like theory of constraints, which I'm a huge fan of, lean, systems thinking. So yeah, those are the topics that I quite enjoy lately. And I'm trying to connect all of these kind of 3 topics in a sense lately. So yeah.
Awesome. And I've been a huge fan of your content for a while on social media, and I was extremely intrigued by the data you've been collecting on async code reviews. So yeah, can you jump on in and tell us about that?
Sure. Yeah, I forgot also to mention I currently work as a principal engineer at HelloFresh, and one of the thoughts that popped up a couple of months ago when trying to help out the teams and advise related to different ways of working. I figure out, there's this portion of I would say also managers, but engineers as well, that would like to see kind of a difference in terms of some kind of data informed way compared to what they're working or the way that they're working on currently. And yeah, I'm a fan of trying to meet people where they are in a sense. So I was kind of intrigued to figure out any possible way to understand a couple of things that I had a hunch coming from XP background related to the async code reviews, which is kind of dominant way of working in the industry, I would say, which includes the async code reviews. And things that I was interested in to understand is the engagement. So that was the first thing, like how much feedback are we able to provide in the async way, and also providing it in some kind of online tool, right, where we need to write the comments or provide our feedback in a written form, right? So because there's this difference coming from the XP pair programming and mode programming, where this feedback is kind of provided in a way more richer form, I would say, which is a verbal one. And so that was one thing that I was kind of curious to see. And the other thing was I was really interested to see what the wait time looks like in this process, meaning how much of a time is this item or this ticket or this piece of work that you're working on stuck waiting for someone's attention, right? So yeah, those were 2 things that I tried to understand first, and then like in this study that I did, which involved I think now 40 plus very actively worked on repositories, I figured out a couple of really interesting systemic insights that really surprised me, and I had no idea that I'm going to encounter. That was a really big learning for me. So yeah, that's kind of how it started. And yeah, a couple of interesting things that I discovered as for the engagement, which I think it's kind of intuitively known as well, is that these 2 metrics, engagement and wait time, also how they compare to the size, meaning trying to see this kind of spectrum and different results based on the size of the PR. And the thing that was really kind of interesting, and I would say also confirmation of this kind of hunch that I had beforehand, is that as we increase the size of the PR, the engagement, meaning amount of conversation that we have between actors in the systems, starts dropping exponentially, right? So I think all of us kind of encounter this, 10 lines of code, 10 comments 1,000 lines of code looks good to me. So trying to, so it kind of mapped also in this scatter plot that I've been doing. And yeah, it's the idea was to trying to normalize the results based on number of non-trivial comments that I get to see on the PRs and based on the size, and then compared by the size. So just to kind of give you an example, if I have 2 comments on PR which has 1,000 lines of code, it's not the same thing as when I have 2 comments on 20 lines of code PR, right? So then trying to normalize this, I got this exponential decay curve, so to say, this power law curve, where with the increase of the size of the PR, and I use really simple metrics for PR size, which is number of lines of code changed, that we get to see this exponential decay in terms of the engagement. So yeah, that was one of the things that was kind of intuitive as well, something that I expected. But then started diving into the topic of understanding the wait time on the PRs. And one of the things that was interesting is just trying to see the magnitude of the cumulative wait time that I saw in terms of the hours, which was at least 5 times more than the processing time, meaning the time we spent working on a given item. So yeah, that was kind of also interesting to see, but also expected in a sense, at least from my experience. And then the biggest learning for me was, that all of us are people that are coming from kind of lean background, advice for reducing the batch size, right? So small batches are good. They reduce the risk. We get value sooner because we release things sooner out of the door and stuff like that. But then what I got to see actually from a couple of diagrams, and again, analyzing this on a pretty big data set, is that if we keep working the same way that we work, meaning with the async code reviews and pull requests, then as we decrease the size of the PR, the throughput of the system and the cumulative flow efficiency starts plummeting. So then my kind of understanding at that point in time is small batches are good, but not necessarily in this way of working. So if we keep working the same way and we try to reduce the size of the PR, and everyone wants to review small PRs because they increase the engagement, we get to review them sooner. We don't need huge time allocation in order to do that and stuff like that. But actually, if we reduce the size of the PR and keep the same way of working, the throughput of the system plummets. So then there's this kind of trade-off between quality, because with big PRs, we are actually not able to get the feedback. So because the feedback exponentially drops as we increase the size of the PR, which means that if we're not able to get the feedback, we are also not able to build the quality in, right? We cannot say the same thing for the left hand of the spectrum where we see engagement. So engagement doesn't have to include quality, depends on the type of feedback that we get. So in this perspective, we lose quality for the big PRs, but for the small PRs, with this async way of working, we tend to lose throughput. So then there's this kind of trade-off that we're forced to make. And it reminded me also of work from a daughter research and accelerate book, right? And the whole idea of the research in the DevOps movement related to the book, which is trying to debunk the myth of throughput versus stability. That is not or relationship, that is not throughput or stability, but it is throughput and stability. And that was kind of interesting to see this kind of relationship in this data, yeah. And that was really a big surprise for me, meaning small batches are not necessarily good because in this way of working, we lose lots of the throughput, right? So yeah.
Yeah, and what's funny about it is it's phenomenal to hear the data. And again, this is data. It's a pretty good subset of data, but it's not like worldwide data or whatever. But it's fascinating to see a subset of data match my experience, because it's kind of like you said, right? Here, someone sends me a 10,000 line code review, and I'm kind of like, oh, this is just too much to even give. So engagement goes really low. And I've been on teams before where people just approve it because they just don't want to deal with it, right? So throughput is high, but there wasn't really any engagement. And then where someone's like, well, what do you think about this line of code? And then I have like 20 opinions, and I'm disagreeing with myself about this one line of code, right? And so, yeah, and so so I really like how this async code review, basically you do have the dilemma, the classic dilemma of speed versus quality, right? With async code review. And so, did you gather any data on teams that were doing something other than async code review?
No, not yet. That's kind of one of the plans, but it's interesting just like having this this mind experiment, thought experiment, trying to see these scatter plots in some other ways of working, which is continuous, any way of working that provides continuous code review, right? Mm-hmm. And so the thing that I forgot to mention actually is that the problem with the throughput was because as we decrease the size of the PR, the wait time goes exponentially up. So the wait time per line of code goes exponentially up, right? So that means actually that the system is telling us that the cost of code review per line of code is going exponentially up as we decrease the size of the PR. And then the consequence of that is that the throughput is plummeting. And the reason for that, again, is that when we think about wait time and processing time based on the size, PR size spectrum, the processing time tends to go like linearly down as we decrease the size of the PR, right? So, I mean, on average, it will take you more time to develop, PR of 1,000 lines of code than a PR of 20 lines of code, right? But when it comes to the wait time, the problem there is that dependencies start kicking in, right? And the processing time you can control as a developer because you're working alone on this thing. It depends only on you. But the wait time depends on the people that are integrating with your work, meaning reviewing your work as well. So that was interesting thing to see that the wait time goes exponentially up because the price or the cost of dependencies starts kicking in with the decrease of the size of the PR. And so yeah, that was kind of understanding that I got from that point. But then the thought experiment about that was, what if we start pairing or mobbing, which is actually we keep the cost of code review per line of code constant as we decrease the size of the PR, right? So if I have someone available next to me immediately at any point in time to review the work that I'm doing, the cost of code review, so the wait time is actually zero, non-existent. So the cost of code review is zero, right? And as I decrease the size of the PR, I don't incur this cost exponentially in the way that I incur it with async code reviews. So yeah, that then the throughput doesn't plummet when I decrease the batch size or the PR. And interesting thing also there was that that the system is actually pushing you into this, if you work in this async way, the system is pushing you into this sweet spot, trying to find the sweet spot between these two things that we're trying to optimize for. And there was one, I think, analogy that all of us, I think, experienced is if you have a slow running test suite, so if it takes you 20 minutes to get a response from a test, right? And the system is telling you, hey, running tests or getting feedback from tests is super expensive. So use it wisely, right? So you, in order to make the wisest economic decision, what you do is instead of running the test after every line of code change, you increase the size of the batch or the amount of changes that you introduce to the system in order to make economic sense out of the slow running test suite, right? And the same thing actually happened with the wait time. If the wait time goes exponentially up as we decrease the size, the system is pushing back, because if it takes me 2 hours to get a review for 10 lines of code, the system is incentivizing me to increase the amount of changes that they push to the next stage for a reviewer, which means that it forces me back into this, trying to find this sweet spot and increasing the batch size. So, and that's the thing that actually I didn't find that it exists with continuous code review, only because of this idea of the cost of code review being constant as we increase the size. So the system is not pushing back. We are able to continue reducing the batch size, which we want to do, because again, all of us want to stay in this small PRs end of the spectrum. So in a way,
Yeah. What I love about this is some of the visuals you have. So we'll have to put those in the show notes. Sorry for those listening, but go check them out. I love how something like mobbing or pairing can sound ludicrous and crazy to people. And then their fallback is async code review. And I love how you visualized async code review with all the, like in a kind of a value stream map where you're showing the two people and them waiting for each other, or the graphs where it's like looping back around on itself. And it's kind of like, yeah, maybe pairing and mobbing is not so crazy if it's compared to that, right? And so I think the visuals really do a big job of that. So have you shared this data with anybody? What has been the results? Have people, been more open to pairing and mobbing after it, or what's been people's reaction, so to speak?
Yeah. So the whole idea or the context about this work was, trying to address this share of managers and engineers that would like to be a bit more data informed when it comes to changing the way that they work. And as you can imagine, it's very difficult to measure quality or speed or throughput, in a sense, in the things that in our day-to-day work and in our industry. So the idea for that was to have this glass of pane where we get to see the results and trying to compare those. And it has been helpful with some of the teams that are kind of interested in this, but I kind of just recently finished this study, and I'm kind of talking about it with different teams and in different communities, which is great to see, because I think lots of teams and lots of people that are trying to get the teams to try the other ways of working are really kind of craving this data in a sense, and trying to to have this conversation in this kind of data informed way, right? Because otherwise it's also something that is difficult, right? Depending on the background of folks, where they're coming from and what kind of environments they have been working in, to understand how does this map to our current way of working. So yeah, I've been talking to a couple of communities, and the interest as I posted the results of the study and the slide deck was really huge, and yeah, I'm really looking forward to share this with a couple of next lined up talks that I have.
Did it have effects like within the organization, when showing it?
Yeah, so as I mentioned, so this is kind of just recently done. I'm on a tour across the org, trying to analyze different repositories from different teams. And I would say, yeah, for some teams, definitely it had lots of kind of impact, in a sense of trying to understand, how much waste is there in the process, and just trying to see, just visualizing the amount of cumulative wait time that is there in the system, because it's also one of the things that they generate in these reports is really, it's hard to ignore. The data is not accurate per se in days, but even if it's like the results are such that even if it's 20% accurate, it's so huge that it's kind of very difficult to ignore. And it's a really good conversation starter, which is kind of the idea that I wanted to have behind that.
How would our listeners at home run a similar report against their own repositories?
Yeah, so I'm kind of trying to make this tool publicly available. It's still not for any kind of commercial use. But yeah, there's a URL link I'll share with you. We can leave it in the show notes where people will be able to try it out for themselves.
That's fantastic. I know in the past, I wanted people in our organization to pay attention more to flow efficiency and less attention to other kind of metrics. And so, I just I had created a chart that was kind of, I refer to it as the Guitar Hero chart. It's essentially deployments per environment per day, just showing, hey, do we get, can we get something out into production within the same day? And trends around that. And so I think, value stream mapping and then also showing time trade-offs and things are really good. And data is a really great way to convince a lot of people quickly. So it's a really awesome thing. And so, and that kind of plays into lean quite a bit too, right? It's just trying to find ways to, show the organization that they can be lean, but they have to actually look, pay attention to what that means. So do you have any more thoughts on lean in general that you wanted to go over?
Yeah. So yeah, it's also interesting. So there's so many things that I tried experimenting with in terms of the metrics that they use. Metrics coming from lean were definitely one of with the biggest focus, I would say. And so wait time, processing time, flow efficiency, and just trying to see the flow efficiency for this kind of work, says a lot per se. But yeah, trying to focus on the also one of the things that I'm really interested in is definitely kind of efforts to reduce the batch size, but also these systemic problems that come into play, which is like Sisyphus, trying to push the rock uphill, and the system is pushing back against you, and trying to understand what are the reasons that are not allowing us to reduce the batch size, and how does transaction costs play into that, and how are we how can we reduce the transaction cost in order to be able to reduce the batch size and use the inventory per se. The other thing that I was interested in also is trying to visualize the amount of inventory that is present. So just looking at the cumulative amount of lines of code, which can definitely have outliers, but it's not about that. It's trying to understand these kind of typical cases, is trying to understand the amount of inventory that we have of the code that is in progress, so to say, that is either worked on or not reviewed currently, and trying to visualize this in a sense across the time series. So that's also one of the things that I've been really kind of curious to see, and how does actually keeping the inventory low, reducing the transaction cost and reducing the batch size affect also the metrics from Accelerate, the deployment frequency, for example, or the change lead time and stuff like that. So trying to connect these two roles in a sense has been a lot on my mind and part of this study. So yeah.
With the low inventory, I think a really interesting metric that you could extract is code unreleased to production. So maybe files that have been changed that are not in production, and churn in those files, and that would just kind of go and show it's like features previously worked on that are getting rework based on additional work that is something unproven, I guess, in production, and that sort of thing. But yeah, it's really interesting. I think in the mobbing environment, I guess in the environment that we're talking about, I think the big difference when you're doing a pull request, it just has so much time that it can live in the system. But when you can essentially get it into production, same day, then everybody pulls that change down and everybody's current when they're doing their work, then you have this effect of, all the ideas are fresh. And so anything that, any problems that arise, you're most equipped now to correct them. And it's hard to quantify that.
Yeah.
Yeah.
Keeping the same context, like, I mean, it's also this cognitive load, this type of inventory that we have, right? That is associated with that.
Oh yeah.
So yeah, I mean, Team Topology's book has a really strong focus on cognitive load, and that's one of the things that also I think happens with a really huge inventory when it happens in the system, and trying to juggle all of these things at the same time, and context switching, and loading up your context with work that is 500 lines of code or completely different thing that they've been working on last week but hasn't been released to production, and all the stakeholders that are involved in this work and stuff like that. So I think it's also kind of part of this, like this mental flow, in a sense, reducing the cognitive load that we have by reducing the amount of inventory that we have in the system as well.
Nice. Yeah. And what I love about this too is I think I was reposting one of your things on social media related to this, and someone made the good point that, hey, this doesn't prove pairing and mobbing is better. It just proves that async code review has lots of problems. and I think that's a good point to consider, right? In the sense that, look, doing this kind of thing like you did, where you gather data and you measure wait time and you measure lean metrics like flow and engagement and these kind of things, you can be like, hey, here's the data, here are the problems. What would you like to do to try to make this better, right? And I mean, intuitively, while there's data still out on pairing and mobbing, like Chris was saying, the time for review is instantaneous, right? It's 0, right? And then if you're in a continuous delivery environment like we are, the time to production is very quick. Have you seen anybody in these initial reactions, I know it's still early, that make suggestions in response to the data other than pairing or mobbing? That they're like,
Yeah, that's a good question. So the conclusion of the study was that in order to not lose the throughput as we decrease the size of the PR, people need to get closer and closer in time, which means that the actors in the system, the author and the reviewers, have to react faster as they decrease the size of the PR. So because the cost is going up exponentially if they keep the same reaction time that they have. So if you go into the low and PR size end of the spectrum, in order to achieve this, so we have to be able to keep the constant or minimal cost of code review per line of code as we decrease the size. And there's one slide that I have in my talk, which it gives the visual that you talked about, these two developers and going async, trying to review a PR and converge on a solution. As we decrease the size of the PR, they have to react faster in order to keep the same throughput that they had before, which means that if you go into the low end of the spectrum, they get closer and closer in time, which means that their availability also has to be higher exponentially than it was before. And in order to do that, we have to do less things that we're doing currently, which also goes back to limiting working process and decreasing the amount of the things that we have in the process at the same time. And that naturally leads to continuous code review. So that's the thing that we actually want to get. Pairing and mobbing are so maybe there are some other ways to achieve that. I don't know. Yeah. But if someone asks me, hey, how can we achieve continuous code review? I know these two ways of doing it, and pairing mobbing become kind of natural thing to do in this environment.
You get closer and closer until you're sitting next to each other.
Exactly. And that's the thing that I wanted to connect in this study, how to match these two worlds that we have, right? And that was really interesting to see, because otherwise we are losing throughput. So, and it's also interesting how it affects developers and managers when you say that they're losing throughput versus that they're going to have a lot more throughput with pairing and mobbing. Because if we take a look at how much throughput we're losing, oftentimes I found that it has kind of stronger effect than trying to say, hey, if we do something else, we're going to be 3 times faster. So this, loss aversion kind of kicks in a sense, and it's also interesting to try to influence the teams from this perspective. Then also interesting thing that was is that as we get closer and closer in time, this online tool that we're using, whatever, GitHub or any other tool that we're using for providing feedback for pull requests becomes a bottleneck in a sense. Because, if you always have to go back and pull the code and run the tests and stuff like that, and everyone else needs to do that, and we have availability, so other people are available, then this tool becomes at one point bottleneck, and then we just say, hey, why don't we jump on a call and just do it, there instead of trying to do it in this kind of, I would say, suboptimal way, also because of there's also interesting interplay that happens there, which is this high latency between the reviewers and how does it affect feedback as well. So I tend to think about it as when I have a phone call with someone who has, and I hear from the other side delay, the conversation tends to die out very fast, which is completely different when the latency is very low, and it incentivizes actors to keep on with the same amount of throughput of feedback that we would like to provide. So that was the thing that we also tend to see in these high latency feedback environments, plus the need to provide feedback in a written form, which is super expensive compared to the amount of throughput that we have in terms of the feedback when we provide this feedback in a sync manner and in a verbal form, which is going back to pairing and mobbing, right? So plus the human interactions and the psychological safety and trust that is I would say even more important thing, but that was not part of the study, even though those are the things that they tend to put a lot of focus on.
Yeah, what came to mind was one of the principles of the Agile Manifesto, where it says, the most efficient and effective method of conveying information to and with the development team is face-to-face conversation. And almost like this almost puts an addendum to it. The most effective and efficient method is conveying code within a development team is face-to-face, right? So, yeah.
Well, so if you were in an environment that had no choice but to be temporally distant from each other, just another thought, putting on the automationist hat here, the idea may be that every code review that occurs that actually yields a suggestion for a change needs to become an automated static analysis or an automated test. And so theoretically, the content of your code review should have to be reduced in action over time, because every suggestion made, right? So like, how many code reviews are out there that are just like, make this variable a dictionary word, right? Like, you don't need to have a person there to do that, right? So if you always said every code review result needs to become a piece of automated software, then that would be another way of reducing the time without getting people pairing and mobbing, right? But the reality is that I think that typically code review has a lot of pressure around it, right? And so you're not going to sit there and write a static code analysis tool to figure out whether or not that person should rename the variable. But this is why we need to stop and automate things as well, because some of these problems do have alternate solutions, but organizationally speaking, it's very hard to actually get there and get it, telling people, hey, let's all talk together rather than writing automation for this thing, is also a little bit easier. And probably you want both. You want to automate the things that you regularly review about your code, as well as have those face-to-face conversations. That probably would end up being the most efficient.
Yeah, and there's automation can go far for some things to talk about, but like I just watched our mob get confused for a very long time on the vagueness of a variable name, right? And so, you know, and static analysis can say it is of a certain length or something like that, but does it correctly express the domain? That is something not
So
at least not
machine
yet.
learning. I would suggest that one day we could.
Yeah, sorry, you know, Chris and I usually get into talking about the future and artificial intelligence at some point. So cool. Well, we are coming close to the end of the show. And was there anything else you'd like to share or plug before we close it out?
Yeah, so I tend to rant on LinkedIn and Twitter, and I have micro blog posts that I publish on my blog. And yeah, if anyone is kind of interested in the rants that they tend to have from time to time, yeah, feel free to connect.
And if anybody out there is experiencing pull request hell of some kind, or maybe they've complained to you, a friend has complained to you about pull requests lately, I would suggest that you send them this episode, share it with them, and help them understand that there may be a better way. And with that, I'll just say like, subscribe, hit the notification bell, all that stuff, and we will see you next time. And thank you, Dragan, for joining us, and bye to our audience.